Hello guys, today we are going to look at doing some more with types and we will see if we can do this serialization thing. Right, let me quickly kill this because this is not important. Just some work stuff. And I will make the screen a bit, the text a bit more legible. So now it should be really big for you guys. And yeah, let's go and see what we want to do. So we have this little structure string. We have this little structure string thing, and for now we just want to get the member names of a struct. So once this works, this code here is the correct type function to get all the members of a struct. We may have to do something about the for each and rewrite it a little, but actually no, this should work. And you will see that here I use auto. I can replace this auto by this. But yeah, that can currently not be passed, which is why I have to do this auto, but it will be an alias array what comes out of tuple_of. So when this works, the static assert with the member names equals x and y being those here, so those here should pass. So let's see what happens right now. We just crash inside of mtype, and we crash because we give that thing an error tuple. So I've already got to the point where I can intercept the interpretation of the tuple_of, because for that you need to know what the alias parameter is. So we assume for now that we have this case where the tuple_of is directly called on a type, as opposed to being called on a variable, which is different. So we will make sure that we get a type expression, or rather we already did that. I just printed the AST type name of E1. It came out as type expression, so we know that this in this case is a type expression, because again we do t.tuple_of and we pass in a type somewhere here, something like this. By the way, this syntax that you have to use a bang to call type functions, that's temporary. Eventually it will be this, but for now I don't want to make it, I don't want to complicate it. Let's see if that already works, though Oh. Oh, it looks like we're dying at the same place. If that would be true, that would be awesome. We're definitely trying to interpret this. So yeah, it looks like we got this syntax to work. So wait, let me check this out. Does this mean this also works? If we now run into the same problem than before, no. We get no property member names for the type S, which is fine so far. We can do the U of CS stuff later, but it is very cool that the regular function call syntax of this already works. I wouldn't have expected that. I mean, this won't work, right? No, this won't work because that doesn't parse. But yeah, but this parses. I mean, why shouldn't it? There's just an identifier. Now, let's see, and get rid of this one. Let's see if we can do something about this returning the correct result rather than asserting. And that presumably asserts because errors don't have a size or something. So let's see, type values as type name, type x. So interpret member equals to tuple of okay. Now what we have to do is we have to look at what mtype does for the tuple of, and I've already found and copied this out. So okay, there it checks if e is a variable. If it is, it does something. We don't care about this for now. Empty sim, this is the member, this is the mtype sim, so basically what we have to do is to say t.isType struct, because this would only work for structs. TS maybe for type struct. If, come on. There we go. So for type structs, TS has a sim, which is the struct declaration, and we basically do almost the same thing. So we do that. And because we don't, EV was for the variable case, huh? So this goes through all the fields and then does this. So this can be for each, actually. We can just do this. We just say F for field, go through the fields. And then we don't have to, we can do set dim, right? And set dim will set the dimension, and then we have the index here. And we can just do X we won't even have to do this. We could just say star exps of I equals new new var exp f, I guess, e dot lock comma f. That's that. And we don't have to do anything to the type, I don't think. Yeah, that's it for the exps, and then I guess what we do is we say result oh no, I need the E0 that I deleted. Though I don't actually see E0 being assigned, so I guess extract side effect would do something to E0. In that case, I will just do a new tuple x with e.lock comma null, because I don't see what else this could be. Exps and that would be that, and I guess I'm not sure if I have to interpret this. I assume ctf.interpret will be called after that, so we'll leave it here. And I'm gonna recompile. Hopefully this, oh. Yeah. MT is not a thing. This is T. No, this is TS actually. Because it's the type struct that we want this thing. We want from that thing. We go through all the fields and MT is mentioned again. Oh, here. Oh, yeah, that's TS. Can I only... Okay. Interestingly, this is not a pointer. Like it usually is everywhere else in DNB. It says only for the identifier EL. It's because this expression is called die. The .id expression. Which is actually a fairly useful expression, so I don't want it to die, actually. Now, let's see. Okay, we don't crash. Which is kind of bad because then GDB doesn't exit. Or did we crash? We had a sec fault? That is presumably because a certain type is not set. So I can definitely see the tuple expression in the member tuple here, so and apparently that thing wants to be casted. Why is that not in the E.E1 maybe? Yes. There's one that has E.E1, E.E2, and they differ in the op. With a bit of luck, I have enum_ty. Type. Type p enum_ty dot article. Okay, it doesn't find the enum_ty thing. That's fine. We just have to try and find this ourselves. It says this cast happens in line 27, so let's see. Okay. Yeah, what will happen here is that this tuple of expression will indeed be cast to a T alias everywhere. So actually I would have to cast all of these variable expressions to aliases, and that's probably the best thing. So let's first set e to a variable expression, and the actual expression that I store in here has to be a cast expression that gets e touch block. Comma e comma type t-alias. So now all of the expressions get cast to t-alias, which we need to do to form an alias array out of those. That could probably already fix our problem. I don't want this. There we go. So now you see the cast to alias being inside the tuple, and I don't know if I feel like we want to create an array rather than a tuple. So yeah, array. Can I do an array exp? Yes. But I want to create array literal exp, which will have the lock. So I create an array literal rather than a tuple, because it doesn't have to be a tuple. There are not different types in here. Well, they are, but sort of in a different way. T-alias is the type T-alias, and the expressions are here. And that should form the array, that I want to be there. So now, as soon as we run this, that should actually now create the right thing. However, it still seems to want to do a cast. And I'm not quite sure why. But we can look at how the cast expression looks in CTFE exp. Cast exp. It's called CTFE cast, huh? Yeah. Eat it up. I bet this is a debug print that I added. So yeah, I would like to know what it even wants to. So we have an array literal. And I actually wonder why aren't the types equal? So actually, so yeah, I would like to know. That should definitely tell us what's going on a little bit more than. Okay, so we want to cast an alias array to an alias array, and I see what's going on. The problem is that the equals method calls type equals, which uses the mangle to compare things, and alias doesn't have a defined mangle since it's never supposed to be out in the open. So what we can do is comparing the types using a different method. So what we can do is let's print the pointers, and with a bit of luck these types are already merged and equal, though I wouldn't think that. But we can try merging them and then we'd see if they're equal. Oh, yes. These pointers are, I mean, they're the same, right? So what we can do, we can just add this check for when those types are actually equal. So we do yeah, we do this. So the place where it fails is when it tries to determine a size, because an alias doesn't have a size, and that gets called in 1614. And 1614 is this, where it tries to determine the size. So that would only happen if we do a reinterpret cast on an array. However, this doesn't need to happen here, since actually those things are equal. So what we can do, if e.type equals, or perhaps even an is to make it even more obvious, is if e.type is type, or that. I'm not quite sure how this operators bind, so I will just, to be safe, put an extra pair of parentheses to not have this blow up. So I think now we should get over this one. We don't. This is weird because, oh yeah, we want to make sure that type is 2, right? And now we definitely go much further. I see things being interpreted here, but it still asks for literal type painting if it tries to compare the type, and that doesn't work for some reason, and I'm actually not 100% sure why this wouldn't work. Yeah, that one's kind of tricky, but we can just look at the code and try to figure it out from there. It's at 451. Here it says if lit type equals type, we can just say if lit dot type or lit equals type. So if they're already the same, we don't go through the equals thing, and if they are, we try to call equals, and I think they should be the same thing. So we do not need to paint anything on there, actually. No. Actually, show me what lit is. Lit is an expression. Show me what lit.type is. Lit.type is null. That's interesting. Show me what E is. Oh. Show me what type is. TY12, I guess that's okay, so that means if lit dot type, because that's obviously not said, and this we return the lit, otherwise we paint the type. Paint type on literal has the same issue, so there we have to do the same thing. And maybe the literal type shouldn't be null, but right now that is the fix. So letter type is null, that's why it croaks. Oh, come on, we have to copy this line again. This is getting tedious. Okay, now we go a little bit further, but we ask if some type is a pointer that is not set. So it occurs to me that these problems we're currently facing, they have one origin and that origin is that we didn't set the type on the literal. And we better do that because otherwise more stuff's gonna break. So why not just do that here? We know that the type is an array of t-aliases. That's it. And with a bit of luck, this helps. It doesn't, but at least we could see what's going on. Okay. With a bit of luck I can print the serial. Of course I can't because the debug info doesn't know it, but what I can do is okay, I see the vtable forecast. Wait. Does this mean lit is a cast exp? That would be weird. But we can certainly find out. Okay, so the literal we are trying to paint is indeed a cast expression. And the cast exp doesn't have a type, which is surprising. I assume that's the cast exp created here. So what we can do is we can set the type on this. We can say this. And then we set the e.type. Which is of course type.talias. It would be surprising to me if that would be the case, because I would assume that the cast exp would set its own type, but maybe that's not the case. Okay. We seem to crash somewhere else. The get value of f seems to have the problem that this value is an illegal CTV value, and we can hack this by instead of set value, we can call set value unchecked in 3930, and maybe we just do that. Here, what we can do is do just temporarily set value without checking. And I'm not. Why do we take the value new val? I don't have an idea. Old value equals new value. That's pretty awesome. And then it gets set. Okay. I don't care. Okay. It tells us it cannot get the symbol from cast alias x in the trace expression that wants the identifier. That's probably fine. So one thing I can do is take the cast out. And 5825. What I can do is, if it is a cast expression and it casts through to alias, or we could say like we can try to just take this cast exp out. Like now I do not do the cast anymore. and I'm just cold setting the type. This almost looks like this works. Can I do this without setting the type? I don't think so. And one of the problems then is it interprets quite a lot of code in here. Let me get that output to somewhere. Array set length impl. I'm not quite sure if why we even get there. Or how far we have gotten in interpreting. Oh my god, this is the array comparison, right? I mean, what we can do is just do a pragma message without doing a comparison. Let's not do this comparison, because then we are starting having to deal with that. Let's rather say member names as and interestingly, what we see now is the X and the Y, just as we wanted. And if we now add a Z here, and now we see the Z. This is good. This is actually great. We will have to clean up the changes that we made, but overall I think we didn't even... Yeah, I mean, the number of changes that we made, this is like super reasonable. I mean, this is like, what, 100 lines? 100 lines change for allowing you to get the member names of thing, and you can even do this traits identifier F, where which behaves really weirdly in the old CDV system, like in the actual Tupolev it behaves weirdly. This now works like just like that, and that's great. And yeah, we got the function called syntax without the bang for free because S is an identifier, and it can't find it can't find the thing. So yeah, this is awesome. So let's do this. And so yeah, we got the member names, there, XYZ, without doing a single template instantiation. I would say this is awesome. And the set array length, yeah, we do have to make sure that all operations on alias arrays do not go through to the compiler, but we can do that. If we want to get rid of this thing just temporarily, what we can do is this. We can just say concatenate equals, I think, and then we don't run into this issue. In fact, yeah, if we do it like this, the compiler will not segfault at all. So yeah, this is pretty neat. But it should be like this. You should not use concatenation in a loop that is bad form if you know how long your thing is. So yeah, no, don't say that. We can take that and post it. Alright, I think I'm done for now. See you all later. No, don't go into studio mode. Stop recording.